Hello, everyone. Let's start with the most important thing. So let me take a photo of you all. Smile, everyone. Say sweatak or something. Yeah,
You're Swedes, you get what you get.
yeah, that's like the most Nordic smile I've seen in my life. Like, perfect. Okay, hello, everyone. My name is Chris, and I'm here to talk to you about AI. There has been quite a lot of AI talks at this conference from what I've seen so far. However, mine will be a little different. I will not talk about any tools, any particular frameworks, nothing about like semantic kernel or any stuff like that. It will be a bit higher level, I guess, but also just going through various topics that I believe you need to know before you even start working on AI application. And you may ask me, hey Chris, why do you even here? Why you're like supposed to talk about this topic? So first of all, I'm software developer. I'm not data researcher. I'm not scientist. I don't have PhD in maths or anything like that. I'm actually a university dropout. It doesn't matter. Like, I'm just software developer, as probably most of you in this room. I used to be for first 10 years of my career doing .NET. I used to be independent consultant. I've mostly done F#, so probably not something that's present at this particular conference too much, but yeah, that's what I've done. And while doing this independent stuff, this consulting, this .NET thing, I've also spent quite a lot of my free time or spare time to work on open source stuff, mostly in the context of developer tooling, building extensions for initially Atom and then Visual Studio Code. And because of that experience and that my expertise in developer experience, I've been contacted in the spring of 2021 by GitHub, and I've joined this very small team. It was like 5 engineers of us back then and maybe 1 project manager, while we've been working on this very interesting extension to Visual Studio Code that you all know as GitHub Copilot. And in my talk, there will be those QR codes. They go to various read more materials. This particular one goes to my Twitter, so ignore it. It's boring. But I hope that other will be interesting. I also yesterday realized that if you sit in the back, you may not see this QR code. I'm really sorry about that. I should have positioned it better. But I will also share this talk on my social media, so you should be able to find it and find all those various stuff. So I work at that team in GitHub or in Microsoft called GitHub Next. And this is the team. We are maybe between 15 and 20 researchers and developers. And our goal is to build the future of software development. We are fairly independent from the rest of the company. We are a fairly senior team. I think we have only like principal plus people on the team, which is fairly unusual if you know structure of these big companies. Usually there is 1 staff engineer for like 100 normal engineers. We have this very experienced team. We are a group of developers and researchers. We have user experience people. We have machine learning specialists. We are a cross-functional team. And our goal is to create the stuff that you don't imagine is possible right now. Copilot was something like that. We also created the new family of fonts, which are using various tricks that no one has ever used to make the rendering of fonts slightly better, and so on, so on, so on. And while we talk about building, most of our projects are using AI. Like, AI is the hype topic today in the world. Like, we see it even on this conference. Like, there is so many AI talks, right? AI is hype. So naturally, a lot of our projects are using AI. And important thing about this particular talk is that, as I've mentioned, I'm not data scientist. I don't know much about like models. Like I know that they work somehow, but in principle, it's black box for me. I just throw something at the model, and model gets something back. So I'm not going to talk much about model side of things. I'm not also going to talk too much about product size of the things. Like, getting project to production is a lot of work. You need to think about hosting the models. You need to think about LLM ops, about if you work on the level like us, you need to care about like, oh, can we get enough GPUs to actually host the models? I'm going to talk mostly about what happens in the middle. So if we have the existing model from existing vendor and we want to prototype something, like what we should do. So nowadays when we talk about artificial intelligence, most usually we think about generative AI. And especially in the context of this talk, we'll be talking about large language models. And this is like one of the annoying things if you're in the topic, that everyone says AI everywhere. Well, in practice, AI has been around us for a while. Like the term itself is from 50s or like early 60s, end of 50s, something like that. And obviously there has been AI winters and then waves of hype over those like 50 years of the existence of the AI as a topic. The recent wave has been really started around 2012 with the deep learning techniques. And you know, right now AI is everywhere. Like if you open Netflix, the stuff that you see on your screen is driven by AI. If you go to Amazon, it's AI. If you open your phone and start looking at photos, it's AI. It's not necessarily generative AI, it's not necessarily large language models, but AI is everywhere. But this mainstream hype that happened recently because of ChatGPT, it's all related to large language models. So what is large language model? Large language model is type of the AI model that first of all operates on the natural language. So you just send English to it or any text to it and it outputs text. Those are massive models. They have been trained on the whole internet basically for the most powerful models. This means that hopefully they're fairly general, like you can do whatever you want with them. At least that's the plan. And they have been trained in unsupervised ways. So you just throw the text at them and you get back model and it does something. No one knows what really. We still every day we discover new things that you can, and by we I mean community around those large language models, discover new stuff we can do with those models. So as I've mentioned, the most important thing about the whole process is that it's natural language model. It understands English, it understands Spanish, it understands Swedish, it understands Polish, any language that it had been trained on. It also understands programming languages, which is very important in our context. Input is just passed as text, as a string to the model. Model does its magic. It then outputs what is the next most probable word in the string. That's all those models do. You send them text, they send you the most probable continuation. All the features that exist right now today, chat APIs, function calling, tools, all this stuff is built on this very basic functionality. Yes, the OpenAI and other vendors have created higher level APIs based on that, but we've been doing a lot of those, and you could do a lot of those stuff using the plain completion API, just by sending the right inputs and processing the outputs in correct way. The models are probabilistic. This means that when we send them the same text next time, depending on your parameters, let's say, you can get different response. This is very important because it breaks your mind as a software developer. Software developers are used to writing the code and then writing unit tests for this code. If you have function that adds 2 plus 2, you always expect 4. You can write unit tests for that. And then for the rest of your life, or the life of the project, you're happy. Like, oh, you have unit tests, it will always work. You know that it will work. Like, if you do refactoring and you break something, well, test starts to be read and you know what to fix. This is not true for those models. You cannot just unit test them, which is, yeah, it's mind-breaking for developers. It was very mind-breaking for me. And as I've mentioned, we don't really know full capabilities of those models. Like, no one knows. Like, OpenAI doesn't know. Like, when we started working closely with OpenAI back on the original Copilot, we've discovered a lot of things that they didn't know are possible with those models. So, yeah, no one knows. And you need to remember that those models are just like going to Vegas and playing slot machines. Like, yes, sometimes you will win and you will get perfect response to whatever was the question, or you will get 100% accurate response, but that's like, you know, it's 1 in a million or like whatever. The probability is probably better, but it's still all about probability. Those models hallucinate. And by the way, the whole space of AI has this like style of using very complex words for describing very simple phenomena. So hallucination is just bullshitting, right? Just for sake of you knowing that. Those models may output something that's absolutely false. And those models have absolutely no idea about that. Like you cannot ask model, oh, is that correct? Like, how do you know that? Because again, the most basic thing that those models do is completing text. If you ask model, was that answer to the question right or wrong? They will output most probable thing. It might be yes, it may be no. It may depend on the like your previous conversation or other part of the prompt. Like you just don't you have no accuracy with that. So that brings us to this thing called prompt engineering, and prompt engineering is name for all the methods that we design the input to the model in a way to steer the behavior of the model in particular direction. So those models are super general. I can ask them about biology, I can ask them about programming, I can ask them about the history of Sweden. But for particular use case, obviously we want to constrain them and to steer their behavior in particular direction. And the prompt engineering is basically the art of string concatenation. So it's all about writing the templates for the prompts and all about writing, concatenating strings. And especially in the social media, you will hear about like, oh, everyone is nowadays prompt engineer because everyone asks questions to ChatGPT, and the prompt engineering is just, oh, how do you ask good questions to ChatGPT? But that's not really true. This is like engineering field. There is a lot of active research happening. There is a lot of white papers. Every day there is like new 10 white papers about different methods for prompt engineering. People are doing serious research around this stuff. So it's not just as simple as, oh, what is the kind of how to phrase the question to the ChatGPT, to the web UI of ChatGPT, but more about this serious usages. So yeah, let's. I think this one is very good link, by the way. This I think so, or maybe next one. I don't remember exactly. I was just finishing those slides. Like I was not at the previous talk because I had to obviously finish the slides. As you know, like if you've ever spoken at the conference, you know that we all finish slides just before the talk. So you can divide the prompt into basically two parts. The first one is kind of like what I like to call constant part of the prompt. It's something that you basically send in your application always to the prompt. In the old days when we just had completion API, it was just on the top of the prompt. Nowadays you can put in the chat API, you can put it into as a system message or a system something, I don't know. This part of the prompt usually is used to describe the persona of what, or rather who model is supposed to pretend to be. So for example, it can be a senior developer working on Python projects. And also to describe the task that the model is supposed to solve. Please show me, or please tell me how to make this code better because I'm a terrible developer. And there is a whole bunch of various techniques that you can use to make this description and of both persona and tasks better. I'm not going to go into details. Again, if you want to read more, this one is great. This one is going to the blog post by one of the very senior people from OpenAI, and she is like describing all the various methods that she found in various white papers in kind of like one paragraph description that everyone can understand. This is a very good resource. And again, this field loves the complex names for simple concepts. So for example, few-shopped prompting just means providing examples in your prompt. of the task that you want to solve and examples of what is expected output for this task. Something like chain of thought is as simple as telling the model, let's think step by step, and let's describe the thought process step by step. And this simple trick, this is actually something that you can do in the ChatGPT, Web UI, whatever, when you do that. If you add, let's think step by step to your every single question, you will get better answers. Even if you ignore the step-by-step processing, step-by-step reasoning, like we very often in our prompts, we ask the model to do that reasoning and then we never look at it because like we don't care, we care about final response. But just because this reasoning is present in the output, somehow that makes the model better. Structured outputs. You can ask the model to output code in YAML, to output stuff that you want it to output in, I don't know, JSON or YAML or whatever different format that you want it to do. Nowadays, this is also functionality that OpenAI especially is adding as a just option in the API. But if you don't want to do that because you don't want to, for example, to be locked in with specific vendor, you can very easily implement the same functionality yourself. And there is also a whole bunch of more complex stuff, like the first one, self-consistency sampling. You can ask the model to output the result in the API. You can ask API to produce multiple responses from AI, and then you do some kind of like picking which one is the best. Sometimes it may be as simple as just majority voting, like if this response is like presented most times in the outputs, that means that it's the best one. You can ask model to ask questions. Like this is kind of like about its own answer. It's kind of like more advanced chain of thought type of scenario where instead of just asking about reasoning, you also ask the model to maybe ask questions or criticize its own reasoning, and then ask for reasoning again, and only then ask for the final question. Nowadays, you can very easily equip models with tools, which is a way of creating the AI systems that also interact with real world. Like model may tell you that it wants to browse the internet, and you browse the internet for it, and then you feed the result of browsing internet to it, and then it has more context to answer you the question. Multi-round systems, obviously the agent is really hype word nowadays also in the space, and agent is basically running the model in the loop. That's all it is. And so on. As I've mentioned, there is like research happening every day on this particular topic, and I'm not telling you that you need to know all those things right now today if you want to start. But it's something that, it's good if you know those words. And maybe you kind of like, when you will go into more research for your own application, you will know where to start. And then there is second part of the prompts, which is something that changes from the request to request, something that's personalized, something that's specific to particular user context. And it's all about retrieval. And there was like the talk about retrieval just before this one, so I'm not really sure. I was not here. I was finishing my slides. So I don't know what was said on this talk. So hopefully I will not repeat too much, or if I will repeat much, it will be fine. Hopefully I will not contradict much, because that will be cringe. It is the most popular word among GitHub Microsoft leadership for like last 2 years. Like if you know, but please, if you know like phone to Satya, don't tell him that I've told you that, okay? And the problem with retrieval, so retrieval is this process of just taking user-specific information, use case-specific information, query-specific information, and putting it into the prompt so the model has more context on what it is supposed to answer. This is very important because for most real-world cases, you really cannot just depend on what model remembers from its training. You want your internal data to be put into the response. You want to have, I don't know, latest version of documentation for given library if you're building chatbots to talk with the documentation. I will have a lot of examples of like programming related examples because that's what we do. So it is one of the lessons that we've learned over and over again, that yes, you need to have a good retrieval and put as much useful information, and useful is the key here, information into the prompt. Because kind of like model remembers some stuff, it may remember wrongly. If you have retrieval, you can even ask model to kind of like tell you from which part of the prompt, on which parts of the prompt this response is based, and kind of like you can do some kind of like checking whether this makes sense at all. But the kind of like the most important thing is that very often when people talk about retrieval, they tell you, oh, you need to use embeddings and, I don't know, vector databases and, I don't know, knowledge graphs, whatever. I want you to remember that those tools may be useful, but they are not necessary for every single application. Retrieval may be as simple as doing SQL query. Retrieval, because you know who is logged into the system, and all you want is get some data that is existing in your system, and you know how to query it because you just want to get some information about current user into the prompt. It may be as simple as looking at different files open in your IDE. That's what we've done in Copilot. It may be as simple as looking at whole repository and kind of like maybe looking at the issues that are open in this repository, or maybe if the original part of the original prompt or part of the input entry point is the issue, maybe looking at other linked issues or linked pull requests. So embeddings, retrieval, embeddings, vector databases, vector similarity, all those buzzwords are very useful if you have a lot of unstructured data and you want to create something from it. But sometimes we have structured data and you don't need it at all. So yeah, remember about that. The very important topic in building AI applications is like, how do we observe results? As I've mentioned, you cannot just unit test your prompts and be happy with them, because those models are probabilistic, they will fail. Even if you set temperature to 0, which is telling the model that, oh, it should always do the same thing for given prompt, because those models are under the hood float, are matrices using float numbers. Because of the float number accuracy, you can still have different responses, even if temperature is 0. Like, this is not guarantee. So there are two major ways of observing results that we are using on every single of our project. One, it is creating offline evaluations. And by offline, I don't mean not touching internet. Obviously, when you use those models, you usually do touch internet because you usually call OpenAI. But by offline, I mean not related to your project itself, not living in your project. In case of the Copilot, what we've done is we've cloned tens of thousands of Python repositories. We found all the unit tests in those repositories. We found the code that they are testing. We've run the unit tests to figure out whether the tests are passing right now or not. We kind of like captured all the state and stuff. We removed the implementation of the functions that they were testing. We then regenerated those functions with artificial intelligence, and then we've rerun the unit tests to see what has changed, like whether we are getting better or what's the passing ratio of our implementation, of our generation. And this is not one-to-one the behavior that Copilot has when you can like use it in IDE, but it's a proxy that can tell us whether our changes in the prompt crafting, in the prompt engineering, make sense and move the stuff into the right direction. You will find that it's very difficult to create evaluation that's like one-to-one, mimicking perfectly what you're doing in your application. Very often it will be like proxy type of stuff with like, oh, it's similar behavior, it's not exactly the same. And because it's not exactly the same, what you also need to do is do something that we don't like to do as developers, but you need to invest a lot into telemetry in your project. And I hate telemetry. You all also hate telemetry as a users. Like, obviously, it's terrible, but it is the only accurate way to really understand the behavior of your AI system. Only. Like, there is no questions here. You need to have very good telemetry. You need to understand whether users are accepting or rejecting, or whether they like or don't like the AI responses. But you also need to, for example, understand whether user, for example, accepted your code suggestion but edited it later, because that means that it was like partially good, not 100% accurate. This type of stuff. So yeah, unfortunately, telemetry is the thing that you will need to do, and I hate that as a user, but as someone that has built a couple of those AI systems, this is the only way that works, which I hate, but whatever. And now let's move to the second really kind of like big part of this talk, which is close to my heart, and it's about like user experience design for those applications. I think that one of the main problems of AI systems is that people, when they hear AI, they automatically goes into direction of chat. Because ChatGPT is so successful, obviously. I guess it kind of slightly makes sense, but it's not the only way. And kind of like I want to share with you a couple of high-level principles that you want to think about when designing user experiences. And also I will share, I think, a couple of examples, if I remember correctly my slide deck. I think the most important principle is like you need to design your interface with user in mind, with human in mind. Those AI systems are not supposed to replace users, because then who will pay for our service? That would be pointless, right? Like as a GitHub, we don't want to replace developers. We want the developers to make productive. We want to lower barrier to entry for developers, so there's like more developers in the world, so there's more people on GitHub. That's kind of the goal. It's not about replacing and destroying software engineering. So you need to remember that those models, again, because they're probabilistic, because they may be wrong, it's very important that user is always in the control of what's happening. You need to make sure that the user have option to stop the process, to provide additional input, to do any kind of like stuff to steer the model into the right direction if it went off the rails. It's very good to invest into like actual user research in front of building of application. It is kind of like related to the amazing talk that was yesterday about like fitting user experience into your developer process. Like if you haven't watched this talk yesterday, I do recommend watching the recording when they will be published. It was amazing talk, and a lot of the stuff that was talked there yesterday, it was not AI related, it was just user experience talk. What was really important is also fitting for building AI systems. I mean, those AI systems are not much different than your usual systems. So please do understand where are the pain points, and also please do understand where your users believe their value is. So in case of programmers love problem solving. They don't like repetitive, boring tasks. So we believe as developers that our value is in solving difficult business domain related problems, or maybe technical also problems like optimizations. We don't like to write 77 unit tests for the same function, right? So if you know something like that, you know where you should target your AI system. To make developer more happy and more productive, we do target those domains that developers don't like to do, instead of trying to destroy what they like to do in their job. Design defensively for failure. As I've mentioned, those models, and I will be mentioning it all the time in this talk, and I've been mentioning it all the time in this talk, those models will fail. This is the core thing that you need to remember. You need to inform your users that those models will fail. You need to design your user experience in a way that signals that it may be wrong. Chat is terrible for that, because chat, when you start chatting with ChatGPT, you suddenly kind of like forgot it's AI. You kind of feel that you chat with an expert, and then you kind of like, you're lost, like you have no idea. Like the original Copilot user experience, and I'm very biased here because it was my baby, but the original Copilot user experience is very clear in signaling to you that it may be wrong. Like it's kind of like this virtual text that it's ephemeral. It can disappear if you start typing the next character. It kind of like suggests you it's kind of like it doesn't have full syntax highlighting, and it's on purpose. because it's all about signaling to the user that it may be wrong. Design the interface in a way that user can retry easily. Like, those models are probabilistic. I've said this word, this sentence, like 10 times already in this talk. But those models are probabilistic, 11. So please do give users option to retry, because maybe the next time the response will be different. Give users the option to iterate on the response. So to provide more context. Yeah, this answer from the AI system is slightly off. It's kind of going in the good direction, but it's slightly off. Let user provide some additional context and ask the model again with the old answer and this additional context. Maybe it will be better next time. Design the system in a way that's easy to ignore. Again, original Copilot is, I think, great example here, because if you don't like response, all you need to do is you keep typing. You don't need to take any extra action to reject or to ignore the wrong answer from the model. You just keep typing. And yeah, easy to modify. Like, the final execution should always be on the human. The final accept, the final save file, the final send this money to this person should be always on the human, and always give option to human to make final edits, whatever was the final results of the AI process. This will be weird, but more accuracy doesn't necessarily mean more value to the users. It all depends on your user interface. One of the stories I can share with the Copilot is that for original Copilot, we haven't used the most powerful models that there were present at the time. We used the smaller model from the OpenAI. Why? Because when we switched to the most powerful model, we found out that it was slower. Usually the most powerful models are slower than the smaller models in terms of latency. And because of that, we were showing less suggestions to the user. And in the end, if those suggestions were even slightly better, like even like 5 to 10% better, in the end there was, if you look at it globally, the product was helping people less because it was showing them less suggestions. So you need to think about exactly what your product is doing, and kind of like latency may be important, it may not be important. Yeah, exactly. If the latency, still staying on the topic of latency, you need to remember that most of those models support streaming. So instead of waiting for like whole bunch of text at once, you can get token by token. I believe that most of the vendors are doing that using some kind of like HTTP2 streaming or stuff like that under the hood. So for some applications, you may use streaming if it's applicable, like ChatGPT Web UI is using streaming, and it's really nice because you can like time to first stuff showing on your screen is much lower. In case of the original Copilot code completions in the editor, we kind of cannot use streaming because that would be super annoying if the suggestion was kind of like adding multiple lines, and so we always waited for to have whole response ready. But again, it kind of like depends on what is your user interface, what is your use case. There is a bunch of traditional, I would call it traditional types of the AI systems or user interfaces for AI systems you can very easily build. Whoops, that's not the button I wanted to click. That was weird. I didn't know my clicker does that. So you can create something that optionally provides suggestions, like Copilot, Google Docs, have it, like basically any application that you use for writing can have such optional user interface. If you have any text box in your system that kind of like that user needs to type the plain text open question type of thingy, you can provide such interface very easily. The other good idea is to have transformation. So user selects bits of content. It may be text, it may be other content, and then user asks the model to perform one of the well-defined actions that you have coded. So for example, optimize this function, or kind of like make all the naming uppercase. Like, I don't know, I'm coming up with weird examples, like debug this bit of code, something like that. This is very good because it constrains the model to particular content, so it doesn't need to perform action on like whole file, but only on selected code, for example. And it's very good because it constrains. You can very well tune the actions that you want the user to do. If the action is not described in the natural language, but it's one of the kind of like actions that you decided are working well in your system, then it means that you can very easily kind of like tune the prompts to be very good. And obviously there is chat. Chat is great because it provides iteration. So kind of like the stuff that I was telling you about providing more additional context and try again, this is very natural happening in chat because that's what chat is. It's kind of like this multi-round conversation. So providing additional context is very easy in this scenario. However, it's very difficult to collect good feedback on chat. Like, people are doing those interfaces where in every response there is like thumb up, thumb down buttons, but people are not clicking those buttons, never. Like, users will never click those buttons. Like, this is terrible. So all those have drawbacks, all those has pros. It all depends on like what is your particular use case and what you want to do. Similarly, you need to understand whether we are more in the world of doing. So user knows what to do. They just want to move in this direction slightly faster and be slightly more productive in typing, for example. And then ghost text, all this like optional stuff is very good. But on the other side is, I don't have any idea what is the next step. What should I do? I don't know. Like, let me discuss what I want. And then chat interfaces are really, really good in such scenarios. So again, kind of like the choice of the interface is really related to the choice of like what your users are expecting from the system. Like, it's not always chat. There is very interesting field in the middle, which is like structured exchange. Like, it is not fully. It's about having this like multi-turn system where kind of the exchange, there's model and then your input and then model and then your input. However, not in fully open, you can type anything into the text field type of scenario as in chat. And we have this project called Copilot Workspace. It's in technical preview right now. You can sign for the waiting list, and like if you ping me, then I will let you in. Basically, the idea of the project is that you point it at the issue at your GitHub repository, and AI is trying to solve this issue and create pull request. So it's about making huge changes across multiple files in your repository. So it's way more complex than the Copilot or Copilot chat. It's kind of like very complex process. However, it's not direct way from issue to code and then it's done, because that would be that accuracy of that would be terrible. Users wouldn't be in the control, and so on and so on. So how do we do it? So first, we ask the model to generate specification based on the like current state of the project. So how your current project behaves given in the context of this issue that you want to solve. What's your project is doing, and what it is supposed to do after the change is described or after the issue is solved. So you generate this high-level specification. We output that to the user. User can edit this specification. If they don't like the answer, they can change something. If model missed something or if model hallucinated something, user can edit it. User is always in the control. Then after this specification is done, we ask the model for implementation plan. So we ask model to based on this specification, this old specification and this new specification, what are the code changes that system is supposed to do? And then we output them to the user. It's the list of like in file test.ts. I'm supposed to add new testing function blah. in the file whatever.ts, I'm supposed to add function x, and in the file whatever.ts, I'm supposed to modify the function I love conferences to make sure that it adds addition to it, it allows additional input, like whatever. And then you have this fairly low-level specification, and if you like it, again, we output it to the user. You can edit that specification. And then only if you like the specification, we then generate the code and generate final pull request. So this means that you are in the control of multiple steps in the process. Like, it's not black box that, oh, something is happening and now you have pull request and you don't know what happened and how you got it. It's all about user control. It's all about steerability. It's all about accessibility. It's all about making sure that you are in the control always. Another example, UI can be something that's another example of UI that's not chat, and it's something that we've also tried to do, is bidirectional translation between, for example, natural language and programming language. You can imagine that in the future, in your editor, next to every single function, there will be natural language summary of this function. And instead of just editing the function, you can also edit the natural language description of this function, and you will suddenly, in real time, also see the changes in the function. You can very easily imagine such user interface. So please do remember that chat is great for some cases, but it's not only thing you need to do when you do AI application. The most important thing to remember is that there is no single path to success. There will be people telling you, oh, you need to use this particular framework and this particular programming language, and I don't know, buy vector database from this particular vendor. It's all hype. Just like in normal software engineering, there is like tons of ways we can solve problems. Some of those tools will be useful in some cases, just like in software engineering. Some of the frameworks are useful in some cases, they are not really useful in other. The same will be true about every single of those LangChain, semantic kernel, Microsoft prompt flow, whatever buzzwords that Microsoft or other vendors are trying to sell you. And yes, it's terrible from me working at Microsoft and telling you that, but whatever. Don't tell Satya. So yeah, you need to remember that there is no single path to success. I can tell you that I think we, as a group, as a GitHub Next, we have maybe 10 finished AI projects, and we haven't used any of those tools ever in any of our projects. We usually just do string concatenation by hand, and it's fine. And if it's fine for the GitHub Copilot, that's probably fine also for at least first step of your experimentation of your prototype. And yeah, you need to remember that after all this that we've talked today about, we are here. It's the start of the way. There's a lot of knowledge in all those topics that I've mentioned. There is a lot of stuff that you will need to care about when you will finally decide to build AI system and push it to production. It's area of expertise, like every other area of expertise in software engineering. Like, you need to know a lot of stuff nowadays to build good front end. You need to know a lot of stuff to build good back end. The same is true about AI. You need to know a lot of stuff to build a good AI system. And I think that the last point I have in this talk, I still have some time, right? Yeah, wonderful. The last point I have in this talk is, should you do it? Like, that's the main question. Should you really do it? If you're, if you work at the company and you're like CEO, CTO, whatever, some vice presidents will come to your team, or even worse, some VC founder, that's terrible, will come to your team and will tell you, everyone nowadays have AI in their system. We also need to have AI in our system. It's kind of like it's on us, developers, to ask whether, is it really a good idea? Should we really do that? Those AI systems are potentially dangerous. And they're not dangerous because, there will be Terminator and, well, kind of like, Judgment Day. Though I must say that I add thank you to every and please to every my prompt just to be safe for the future. But I assume that it's not Judgment Day Terminator kind of scenario. Those models, those systems are dangerous because they have real world impacts on the society, on the users, on the people today. It's not about, oh, there will be AGI in the future and will destroy all the worlds, all the jobs. But maybe, if you create the system that pretends to be a mental health specialist, maybe you shouldn't use AI for that. That was one of the things that happened after GPT-4 was released. There was this web service that was originally used for connecting people to the mental health specialist if they cannot go in person to mental health specialists because they are poor or in area that there is not a lot of such help. And this system suddenly announced, the people building this system suddenly announced that, oh, for the last 2 weeks we've been testing replacing some of this mental health specialist with the AI without informing users in any way. I mean, I don't know what to tell you, but probably you shouldn't build such system, even if your CTO asks you to do that. I'm fairly sure that there will be people. Oh, I actually heard this from someone. I cannot say who because it's kind of like internal knowledge. But there will be people using this type of AI to do some financial analysis, fraud detection. And fraud detection is traditionally very good field for AI. But for traditional AI, like traditional machine learning, building models on real data, it's probably not the greatest idea to use GPT-4 to do fraud detection. Like it has absolutely no context on like financial stuff. I imagine that that right now today, because ChatGPT got so popular, there are people that ask about I don't know, the tax returns or like whatever the forms that they need to fill for the tax reasons. They're asking ChatGPT about this stuff, and ChatGPT, pretends it's the smartest person in the world, and they will output something to them. It's probably not a great idea, right, to do stuff like that. And I think the most important thing that I also want to mention is that the vendors nowadays provide all those statistics about, oh, this is hate speech, oh, this is sexism in the response or in the input. But really, this is okay on like second level, on the technical level, when you have working chatbot and then yes, filtering based on those kind of like statistics is pretty good idea. It's definitely a good idea. But really, realistically speaking, when we talk about responsible AI and about ethics in AI, what you need to think in front is whether this use case is actually good. It's not about technical details of like running some filter on some inputs or some outputs. It's about how the system will impact our users, how the systems will impact society. So yeah, please do think about that when you do those systems. And that would be it from me today. I'm around today if you have any questions. I don't know if we have time for questions right now, do we?
3 minutes.
Yeah, we have 3 minutes for questions. I actually have 2 more slides, so it will be quick. No, I need to, sell some stuff to you. There is a really good book by Albert Stigler and John Berrimon. Albert was one of the original Copilot people. He worked for us for multiple years on Copilot. He is now doing some startup. And Albert is amazing, and this book will be amazing. So this goes more in depth into the prompt engineering. Albert is probably the best in the world expert on the prompt engineering after all the work that he has done with us, or maybe what I've done for him. And then the second book is from my amazing friend Philip Carter, who is working on Honeycomb, people doing open telemetry stuff. And it's like 30 pages report about observability for large language models. They are like world-leading experts on observability in general, and also they have running AI system in production, so that Philip was responsible for, so they know what they talk about. And yeah, thank you for watching. That was fun.